Welcome to our next section, learning programming in Java operators. Okay, we're moving along the course, and now it's time for the operators. Hey, we don't have a lot of money, so I'm going to recommend some, I think, the best value books out there for you. If you want to follow along with these books in the course, they will align very well. Okay, just a quick note, you're going to need JDK 8 or newer. You're welcome to use the newer JDK 8 installations, except we're not going to use any of the features in the later languages. They're just not important to the core part of Java. But what is important is getting a quality IDE, and that's IntelliJ Community Edition. It's free. The Enterprise Edition will work, of course. But these are the two requirements that you need for the course to install JDK 8 and IntelliJ Community Edition. Once again, I'm Hugo Scavino, a little bit of self-promotion here. Been doing this for 30 years. I started doing Java since the beta, so it's been a long time. I primarily used what I needed to use to get my job done. I taught this class in various countries, UK, France, tons of Fortune 500 companies out there. I've been a senior software architect with companies like DTC, Penske, HSBC, and lots of government agencies. So let's get on to the next slide. All right, what's the topic? It's operators, specifically arithmetic operators, relational operators, logical operators, and assignment operators. We'll talk a little bit about unary operators. I think the best way to learn these things is just to take a look at the code and the examples. Once you see what they are, I think you'll realize how straightforward they are. All right, probably the most important operator, and the one that you're going to use every single day, is the assignment operator. You're going to assign a value to a field. Sometimes it's a literal. It could also be a field value assigning to another field value. The syntax is pretty straightforward. There's one here, int x equals 100, x now equals 100. As I was saying, you can also assign a field variable from another variable. For example, int y equals whatever x is. So in both of these instances, you are assigning a value to a variable, and the assignment is done with the equal sign, which is probably not surprising. Okay, let's look through this assignment. Int x equals 100. So the variable x is now given the value of 100 of type int. Int y now equals the value of x. So now y is given whatever x is currently set at, which is 100. Next, we will set x equal to 200. If we print out the value y, what do you think y will be? Give it some thought. You're assigning y equals to x. Explicitly, you're assigning the value of whatever x is to y. So your answer should be 100. It's not 200 because you're not assigning the reference or pointer to x to y like you might in C++ or C or some other language. Here, int y equals x merely means take whatever the value x is and shove it into y. Y will always now have 100 until it's not 100, or you change it somehow, or you null it out. The fact that x changed to 200 doesn't mean anything for y, because y has had its value of 100 and will retain that value until it's changed. Okay, we got another puzzle for you. What happens if you assign two classes to each other? What happens to their field values? Specifically, let's say you create one class, type A, class B, and then you assign one class equals to the other class. So you assign the reference of class A to the reference of class B. Not the fields, but one class to another class. What happens to the field values in the class that gets assigned? Does that change, or does it stay the same? Let's find out. All right, specifically, this is the example I am referring to. I have an order class. I create an order 1 and an order 2. I assign them different values. Okay, and let's print those out. As you might expect, order 1 has a value 1001, and order ID of order 2 has a value 2001. So you create two classes, you assign their fields two different values, and they have two different values when you print them out. Makes sense, right? Okay, so what happens here? Okay, I have an instance of the order class called order1 and an instance of the order class called order2, and I assign them to each other. What do you think is going to happen when I print them out? Assignment, remember from int equals 100 and then it said y equals x in the previous example. Well, the same thing is happening here. I am going to override the fields in order 1 with whatever the values are in order 2. So again, the assignment operator is acting like you might expect. It's assigning everything in order 1 with whatever is assigned to order 2. So when I print these out, they're actually both 2001. So if you're not careful and you assign a whole class to another class, you're overriding everything that was in the previous class with the values that's in this from the other class. So order 1 field values now have everything that is in order 2. Surprised? Well, it's assignment. Okay, what if I pass an instance of an object to a method and that method manipulates the fields of that class? What will happen to the fields once the method is complete? Let's take a look at that in the next example. All right, it does get harder, so hold on and let's go through this together. What if I pass an object, let's say of type invoice, to a method and I change the fields inside of that method? So take a look at this example. I have an invoice, I create new on the invoice. I set the invoice ID of that invoice class to 100. I take that object of type invoice and I send it to a method. I send not the invoice ID but the entire class. I send the entire class invoice to this little method called process invoice. When I change the invoice ID inside of that method with its object instance of type invoice, which I call here I, and I add 100 to it, well, as you might expect, whatever you pass in will get added 100. But what happens after you process the invoice? Does the invoice ID remain 100 or is it 200? Well, the answer is it's 200, because when you pass in the class instance to a method and it changes the field values inside of that method, then when it comes back out, it remains changed. So let me say that again. If you create a type and you create an instance of that type, you set up its fields to 100, then you pass the entire object, all of invoice, to a method, and that method changes the fields. When you are done with that method, those fields are now changed. So passing a reference of invoice to a method means when you change those field values inside that method, they remain changed. So you're not making a copy for one-time use inside of process invoice. You are actually passing the invoice object for you to manipulate. So depending on what your history is with programming, that may be a surprise to you, but that's how it's done in Java. Okay, this should not be that exciting. These are mathematical operators. Java will let you do math. So you can do plus, you can do minus, you can do division, you can do multiplication. There is some precedence, but you don't need to worry about that as long as you put parentheses around your math. The one thing you can't put together is like two booleans. So for example, if you create a boolean called sleepy and it's true, you can't do sleepy plus sleepy. You can only do numbers, or primitive numbers to be exact. Now there are some exceptions to those rules, but we don't need to go over those right now. Okay, this is unnecessarily tricky. It's always on some exam, and sometimes there's a bug, and this is the shorthand version of doing these kind of increments and decrements. Personally, I don't do this shorthand because, well, this is why. Look on the left hand side, x equals 100. Then I sign z equals x plus plus. So what's z? Your answer may be depending on where you come from, what language you might be used to, but here in Java, z equals 100, then x becomes 101. So the assignment happens first and then the increment. the opposite is true for decrements. Again, I assign k to equal to 100, and look at j equals k minus minus. As you might imagine, I do the assignment first, so j equals 100, and now k equals 99 because it's been decremented. So when you have the decrement and the increment on the right hand side, the assignment happens first. You may want to pause and take a look at both of these things just to make sure you understand. When it's on the right, the assignment happens first and then the math. So now the operators are on the left hand side. So what might you think will happen? Well, it's actually the opposite, right? So z gets assigned the value of x after it's been incremented. So z now equals 101. Correspondingly, j gets the value of k after it's been decremented. So now j and k are 99. If you want to go back to the previous slide and compare that to this slide, make sure you understand the two. This is obnoxious. This is tricky. You can get some real interesting bugs this way. You need to know both ways to do this. Personally, I don't like mixing the two, and I also like drawing that out. I don't like the plus plus and minus minus on either side. It's just a little bit confusing, but you need to know what it is. These are the relational operators which you will love and adore. There's less than and greater than, less than or equal, greater than or equal, equals equals, and not equals. These are exactly what you think they might be. If you want to compare one being less than the other or one greater than the other, these are the same ones you learned in basic math. When you want to compare if two are the same, this is not assignment, this is testing equality, it's equals equals. And to test that it's not equal, it's the bang equals. You have seen this in other languages and other syntax. It's all the same. These all produce a boolean result of true or false. There's no middle ground. Okay, what do you do when you're using the integer classes or the other kind of mathematical classes? Well, you gotta use the value of, and then you can use the greater than and less than. Be careful of the equality operators. You still want to use equals when you're creating or using an integer to an integer. Remember, I'm not saying int. Okay, I'm not saying int. I'm talking about the integer class, intger. Take a look at those, and be careful of having accidentally putting a null in one of those classes. You will get a runtime exception at that point. When you want to compare two integers, use the dot equals. Don't use the equals equals. Okay, this is a topic unto itself, which we won't cover here. When you want to compare two classes that you have created, you want to override and create your own equals methods. You can't just use equals equals. This is for classes that you create. Now, when you are using classes, the people who wrote those classes have created equals methods and implemented them correctly, hopefully. But when you create your own class, you have to implement your own equals, and you have to compare the fields that make business sense to you in order for the method equals to make sense. Okay, now we're getting into some real data science. These are the logical operators. So when you say something and something must be true, then it's amper. If it's something or something else, then it's pipe. And to say something is not something, it's the bang. Okay, so amper is an and. All expressions must be true for the entire expression to be true. The or is as long as one of the expressions is true, then the whole one of those, and if one expression is true, then the entire expression is true, at least one. For the and, they all have to be true. Let's take a look at an example to see how that works. Okay, let's take a look at these logical operators examples. Currently I'm 16. The adult age is 18, that's why I have a final there. And by default, I have parent permission. In the first if statement, I check for the or. All right, so I either am above 18 or equal to 18, or I have parent permission, and if so, I can attend the party. In the second one, it's an and condition. I need to be both equal to or greater than 18 and have my parents' permission to do whatever I need to do at this party. That's got to be some party, because regardless of how old you are, you need your parents' permission. Seems kind of wacky, but you get the point in terms of ands. The third one is not. So if you don't have the parent permission, then do something. I do want to point out one more thing. And that's the short circuiting. Okay? In the first if the condition is met that I am over 18 or equal to 18, then I don't need, or the compiler won't need to compute everything after that. So you will not actually check has parent permission if you happen to be 21. It will short circuit and just do the first part. Depending on how you set up your code, that may or may not matter. Hopefully it doesn't matter. But you should know that the compiler is not going to continue checking every permission in an OR. As soon as one of those ORs is true, then it short circuits, the whole thing is true, and it moves on. For the second one, all of those conditions have to be true. So the compiler will check every condition one by one and then tally them up, and if they all are true, then the entire condition is true. If each individual condition is true, then the entire condition is true. Okay? Okay, I hate this thing. This is the ternary operator. So the variable is equal to some condition, then you have this question mark, and then that's the first expression if it's true, and then the second expression if it's false. All right? It's a weird syntax. Every time I see it, I hate it. I make it more complicated so it's more readable. I don't like this one-liner, but you see it a lot of times and you need to know what it is. This is the ternary operator. It's a shortcut. It's a quick way to do some logic. The variable will equal whatever the condition is. If it's true, it will equal the first expression. If it's false, it will equal the second expression. Looks weird. Let's take a look at an example. Okay, so here's the example. So can I vote? So if you pass the age into me, I will calculate the age, and if it's true, then I will return a string called eligible to vote. If it's false, I will return a string called not eligible to vote. This is kind of the simplest way you can do a ternary operator. It doesn't have to be strings. They can be numbers. They can be much more complicated objects. Personally, I hate this thing. I hope you don't use it, but you need to know what it is when you see it out in the wild. All right, good news. So what did we go over today? We did arithmetic operators, relational operators, logical operators, and assignment and urinary operators. The arithmetic operators are what you may think they may be: plus, minus, multiplication, division, and other math. The relational operators will about relations. Is something not equal, less than, greater than, equal, less than, and equal, or equals equals. We also looked at logical operators. Those are the ands, or the ors, and then the bang. So if something is an and, then everything must be true for the entire equation to be true. For the two bangs, if any one of those conditions equals true, then the entire condition is true. We talked about assignment operators and how tricky they can be. Int equals y is pretty straightforward, but what about when you assign a class to another class variable? It gets a little complicated. And then we did not. Then we talked about the incrementers and the decrementers. So if you have questions, leave them in the comments. And thanks a lot.